All right. Any questions? Anything that you guys would like to go over from the homework?
Everything.
No.
Honestly, like any question from like the 5.1 and 5.2 would be fine. Yeah.
5.1, 5.2. So give me the question that you have. Uh,
Let me just put my last answer.
that was like the contingency table, I guess. And yeah.
The player gets 106 shots out of 150 free throws. So how would I word that?
So
How?
so say it again. The player gets 150. Uh-huh. And what's the question?
How many?
What's the probability of him making the next shot?
Yeah,
This is the answer.
15. So the answer is already there.
Mhm.
And I have a question. Are you kidding me?
Yeah.
So what's confusing for me is
Mhm.
just the wording, I guess. I always have an
Mhm.
issue with the wording when it comes to math.
Got you.
Two marbles are drawn randomly, one after the other, with a
Okay.
placement from a jar that contains 6 red marbles, 2 white marbles, and 7 yellow marbles.
Okay. Six red, two what?
6 red,
Uh-huh.
2 white,
White.
7 yellow marbles.
All right.
Remember that 2 marbles are drawn randomly, one after the other without replacement.
Okay.
Find the probability of the following events. A red marble is drawn first, followed by a white marble. A white marble is drawn first. I'm sorry, a yellow marble is not drawn at all. And the white marble is drawn first by a white marble. And a red marble is drawn first, followed by a white marble. That makes sense.
Wait, say the last one again.
A yellow marble is not drawn at all.
Yeah, I got that. What was the one after that?
The way you writing it is so simple. The way you teaching it to us is so
Mhm.
simple, but then I go on the homework and the homework is diabolical.
Really?
Yeah, it's
Oh,
so.
we'll talk about it.
What you teaching us is so
Mhm.
simple. Yeah, that shit just goes left.
Ah, but this is good. Well, what was the last question? A probability or what? Let me see the last one.
It's not,
No, no, after that.
like, what's the probability of that?
That's it.
Yeah. The probability.
So red and white, right? No replacement.
Drawn first, followed by a white marble, that's
All
the
right.
first one.
So what's the probability of you drawing a red?
So it says that there's 6 red marbles.
Okay, so 6 over 15. Let me see. 6 is 12, 13, 13, 14, 15. Yeah, yeah. Good, 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 good. Times, what's the probability of you drawing a white marble?
So there is 2 white marbles,
2 over what?
15.
No.
No,
I,
40.
you said I took one out already, right? So how many's left?
12 or 14.
All right.
You see that that's so
Yeah. And then that's the answer right there. I mean, you got to do a little multiplication or whatever.
and then you get
Right.
you get 12 over 210.
And that's the answer.
Oh.
Now, mhm,
Yeah, it says 5.2.
mhm.
And then the second one is a white marble is drawn first, followed by a white marble. You see
Oh, I didn't see that. So white and white.
white and white, yeah.
All right. That sounds like a crime. All right. So what's the probability you drawing a white marble? Not one, two, right? That's the first one. It'll be 2 out of times 1 over 14. And that's it.
So why does the wording have to be so confusing? Are you gonna confuse like this on the test?
Mm.
Yeah, like.
Yeah. Hey, how are you? I'm happy you went there. Good job. Yes, yes.
But the way you're reading it on the whole
Mhm.
is so diabolical.
Yeah. So, there's a there's a microwave downstairs. That microwave is strong. Like 1 minute is a lot. Yeah. No, no, it can do more.
Try taking a
That yeah,
then.
yeah. That microwave is real powerful downstairs. Yeah. There's another microwave in Roscoe Brown. Yeah. Yeah. Got you. I got you. I got you. So what's the probability of no yellow? Well, how many colors are not yellow?
Oh.
Close.
So you wanted to know how many
8,
yellow and
right?
how many red and white?
Right, red and white. Right. So red and white would be 8 over what? Good. Times what?
Times 0 over 15?
No.
Times 7 over 15?
7 over
15.
7 over no. I took one out. How many's left? 14. That's it.
No, you took
Yeah. Mm-hmm.
So Professor, do you get what I'm saying? Like,
Yeah.
your lesson was so simple, and then I
Mhm.
go on the fucking homework, and I'm like, what the fuck?
This wasn't the same thing as a lesson? It wasn't?
No, look at how simple you made it.
Really? I don't know. I
You
don't
made
know.
it. Why don't you?
I mean, just ask and I'll do it. I mean, the multiplication is the hard part.
No, I'm afraid of what you wrote. It's paragraph. I don't understand.
I don't know. These earn questions, they're fun. Any other questions from the homework you guys have?
They got
Uh,
there's questions from the whole week.
Mhm.
Just read and continue.
So we didn't get to that yet. We're gonna get that today. But discrete means countable, right? Continuous is something that just like keeps going, you know?
Yeah.
So like the number of students in this class is discrete because I can count how many I'm here, you know? But if I have a situation where I can't count, like I can't get like a whole number, that's continuous. Yeah. But-
Okay, so like, this question here says the sentence in any given location, that would be continuous.
Right. Yeah. Anybody else? You good? All right, let's jump into the lesson for today. It's gonna be a fun one. Mhm. Yeah, that next day for that. Yeah, next day. But you got time. You even got time next week to do it because we're not talking about the test till like Thursday.
Is it?
Yeah.
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 The whole part.
Really?
Bad.
Well, y'all good.
Like such a short time compared to the other one. I'm not gonna lie, Professor.
It's been a minute. Like, when did we have our first test? Like September? Yeah. Nah, in like September. Yeah. It's been, yeah. Nah, like you have more time for this. Yeah.
You said just follow the homework, right?
I mean, I'm just copying and pasting the homework, so I mean it is copy and pasted from the homework, I'll be honest. Like, but I'd be picking out like really, really specific questions, which I'll tell you why at the end of the semester. I mean, that's how I do it. Mm-hmm.
So like the fact that we have gotten comfortable with the check your answer theory. So like if I put if the answer's wrong in web work, I have the opportunity to change it.
That's what I love about it. Yes. Yeah.
Handicap fund, because
Why?
they take the exam, I don't have that luxury of saying like, yeah, but I have my background, this is fair, okay, I was like this, or be able to catch.
Yeah, you do. That's why I let you go to tutor and I give you half the points back. Every single test, not on the final.
Three and three.
You saying.
There's six, three.
Okay, good.
Really?
Yeah.
I got an eight?
Mhm.
Really?
Circle this for me. All right.
I got an eight.
Yeah.
I got an eight with this.
Well, I need time to computer, you know? Yeah. Yeah. Mhm. Yeah. I got y'all with that. What the hell is this? I don't even know what this is. All right, let's talk about this. So we're doing introduction to random variables and probability distributions. Yay. So random variables. For our purposes, we say that a statistical experiment or observation is any process by which measurements are obtained. For instance, you might count the number of eggs in a robin's nest or measure daily rainfall in inches. That's where I heard something. All right. It is common practice to use the letter X to represent the quantitative result of an experiment or observation. As such, we call X a variable, right? So let's talk about random variables. So a quantitative variable, X, is a random variable if the value that X takes on in a given experiment or observation is a chance or random outcome, right? A discrete random variable can take on only a finite number of values or a countable number of values. Yeah, a countable number of values, right? A continuous variable can take on any of the countless number of values in a line interval, right? Blah, blah, blah. Think of it like this, right? So I can count how many people is here, right? That's discrete, right? But I can't tell you the temperature outside unless I like use a decimal to be accurate, you know? That would be continuous, for example, right? So that's the big difference between them. Discrete, you can count. Continuous is like any other number. Yeah. Yeah, but like you can be more accurate with it, you know, like what's this guy's name? Victor Wembanyama is like 7'7". His height is like continuous, you know? I heard he grew like 2 inches like over the summer or something. Jeez.
Continuous is what, counting?
Continuous is not is any number, but what you call it, discrete is countable. Right? Oops. Wrong thing. Hi. I was just asking about you too. You're gonna live a long time. Good. Hey. So the distinction between discrete and continuous random variables is important because of the different mathematical techniques associated with the two kinds of random variables. In most of the cases, we will consider a discrete random variable will be the results of a count. The number of students in a statistics class is a discrete random variable, such as 15, 25, 50, and 250 are all possible. However, 25.5 students is not possible, is not a possible value for the number of students. Most of the continuous random variables we will see will occur as a result of a measurement on a continuous scale, right? For example, the air pressure in an automobile tire represents a continuous random variable. The air pressure could, in theory, take on any value from 0 pounds per inch squared, PSI, to the bursting pressure of the tire. Values such as 20.126 PSI or 20.12678 PSI and so forth are possible. All right.
Professor, for discrete, I put a variable that has separate countable values, like 1 or 2 or 3 cars. And for, which one's the other one, Professor?
Continuous.
For continuous, I put a variable that can be any number, like weight or time.
Pretty much.
I just want to make sure ChatGPT is not messing with me.
It's all good. All right, let's look at an example real quick. All right. So this says which of the following random variables are discrete and which are continuous, right? So measurement of time, it takes a student selected at random to register for the fall semester, right? Time can take on any value, so it's a continuous random variable, right? Count the number of bad checks drawn on the upright bank on a day selected at random. Number of bad checks can be only a whole number, such as 0, 1, 2, 3, and so on. This is a discrete variable, right? Because you can count it. Yeah, go ahead, I got you. Right? The measure of the amount of gasoline needed to drive your car 200 miles, right? So we're measuring volume, which can assume any value. So this is a continuous random variable. Pick a random sample of 50 registered voters in a district to find the number who voted in the last country election. This is a count, so the variable is discrete. All right? And that's it. Any questions on this?
I'm just gonna write them down and then ask for the ST.
Sure. Yeah. Y'all registered to vote, right? Honestly, I don't even know yet. I gotta read through all of this. Next week, Tuesday is voting day. We still got class, by the way, so y'all know. All right. Yeah. Yeah. I'm thinking about voting like on Friday or something or Saturday. Yeah. Like, yo, definitely. Like, you know why I love voting? Them damn pens. They got the best pens, yo. Pens. Yo, that pen is fire, yo. Yo, I love that. Yeah. Nah, but real talk though, there's a website that I like to go to. It's called who'sontheballot.org, and it actually gives you your entire ballot before you go. So you can know who's running for what and what's up and all of that stuff. So you can do your research. Like that's my advice to y'all. Do y'all research before y'all choose. Like don't just blindly choose like everybody else does. Yeah. Yeah. Like ballot proposals and all of that.
It tells you.
This what I really want to read about.
Hold on. I'm sorry, I'm all in your stuff.
Nah, you fine. You can take it if you want. They got a whole bunch of other ones.
Now I have one in my house. I was reading like they stuff and like I was basically starring and circling the
Yeah.
that, yeah. And they tell you, I didn't know we had a borough president.
Yeah. Matter of fact, you know what? I think it was like 2 weeks ago she was here. Yeah, she was over in like Google Moore. They had this big luncheon or something like that. Ain't nobody knew the Bronx borough president. Yeah, we have a borough president. Yeah. Vanessa Gibson, whatever. Yeah. I think she's running too. Yeah. Yeah.
Okay.
Come here, let's talk. Yeah, come here. So, that's wrong. No, these are all right. Right, if you see a red check, you're all right. Oh, it's not right. Right? That's not right.
You see, I erased it.
Got you. This is not right.
You should talk to them. That's messed up.
It happens. It happens. You're not the only one.
And this
The
one,
median is wrong. And where's my standard deviation?
okay, wrote it on thing.
Yeah, so I need it here.
Let me see if I find
I
it.
know that's it. I really want to see some work.
This?
Yeah.
Isn't this the?
No, like the top of that. This is right. This is right. But I want to see the work for the standard deviation. So,
Right.
Yeah. Yeah.
So the answer are the ones next to it, right?
Yeah, that's right. Yeah.
So measure would be continuous, right?
Mm-hmm.
Count would be this way.
Exactly. Oh, I'm sorry, my fault. I'm sorry about that. All right, go ahead. Yeah. I like the can. Yeah. From that company, that's the only version of their product that I like. Because the rest of the versions are in plastic, so yeah. Mhm. Oh yeah.
So after practice.
Do the ones in your homework first and then ask ChatGPT for those. Yeah. On the what? Oh yeah. Y'all gotta go. Joy's fine.
It's here, I'm doing it with her.
Yeah.
This little. Yeah.
It's all right. I be asking y'all hard questions, so that's why the tutors be getting knocked out. That's fine. But they good. I'm just joking with y'all. All right, so look, probability distribution of a discrete random variable. What's good, man? How you doing? All right, good, good. You can't complain, man. All right. I'm still in pain, but I'm here. You know, yeah, I'm just limping around. You know. All right, so a random variable has a probability distribution, whether it is discrete or continuous. A probability distribution is an assignment of probabilities to each distinct value of a discrete random variable or to each interval of values of a continuous random variable. Cool, right? All right.
Oh, this is a new one, so make
Mhm.
other word is what?
That's it. That's what this distribution is. Now this next part is like it's not gonna come as a shocker. It's nothing new that you didn't know already, but just to complete the whole idea. You know what I'm saying? So features of the probability distribution of a discrete random variable. One, the probability distribution has a probability assigned to each distinct value of the random variable. And two, the sum of all the assigned probabilities must be one, right? Which we all knew that already, right? The sum of all the probabilities have to add up to one. All right. This homework is open, right? I'm not even sure. It is, yeah. Yeah, I got y'all.
I'm still writing the probability distribution, definition.
Got you. I'll give you a second. No worries.
Are we doing?
Not right now. We're like learning how to do the homework for today.
But if you have a question specifically from your homework, give it to him and he'll solve it right there on the board for you.
Mm-hmm. Or if we run out of time, go do it in tutoring. Yeah.
Well, we did the tutoring and clearly it was wrong.
It's just one question though. It's not bad.
Three questions. I got
Yeah.
three.
But you know why some of them was wrong though? Like, how can I say this now? There was a question that I asked, and y'all just added more to it. So I'm just like, yo, I just need one answer. That's it. You know?
You can't give us a test.
Yeah.
That's the academic or the
No, no, no.
who's wrong.
No, no. So that's for the secretary, right? That's not for you guys. Yeah. But yeah, you can just walk in if necessary. You know, like if you need it last minute. Yeah, but they just asked that if you could make an appointment, make the appointment. Yeah. Go ahead, right? But
Yeah. That's.
it don't matter. You can walk in on Zoom too if you want. Yeah, yeah, yeah. Yeah. The Zoom is one-on-one. But in person, I'm gonna be honest with you, right? You see, like right now, if you go to tutoring, everybody did their midterms and stuff like that. Ain't nobody in tutoring right now. You know, like yeah, it was packed because yesterday was still finals, midterms. Yeah, you know, so yeah. Hmm.
Is it illegal for you guys teachers to
Hmm.
give us, you see how this is a test?
Yeah.
Why you can't give us the test blank? Just change the numbers and names for the real test.
What do you mean?
Like, you know, like,
Yeah.
this is the test, take it home, fix it, whatever.
I'm in agreement.
But that is what I'm doing. And
You
then,
can't give us this before we take it.
yeah, just take it first time here. Yeah. I mean, technically, you had all the questions already. I just copied it homework. I'm just choosing the easiest questions out of the homework. Yeah.
It's better.
Mhm.
I mean, that would be.
No, we all
20?
understood it better. We was all.
Yeah.
Great answers. And this time it's gonna be a linear equation. Radical.
Mm-hmm. Literal equations, this stuff, you know? Yeah.
Final example, we all prepare.
We'll talk about that in December. Yeah. We'll talk about that in December. Yeah. Not really. I mean, didn't you get an A also?
Actually, I got it
Yeah.
now.
Yeah.
You got an A on the first try. Yeah. Yeah.
Yeah.
What I got on the first try, Professor?
I don't know. You got an A now. That's all that matters. Yeah. Yeah. Yeah.
Well, hopefully allow us to see
You
The
see
formula
this?
sheet, all the answers was there, right? Yeah, see? I told y'all. Yeah. Yeah. Really? All the answers are there. You just got to copy.
See, so
Yeah.
his understand
Yeah.
the formula sheet. I'm not that.
I got you. I got you. Don't worry. I got you. All right, let's look at this discrete probability distribution, right? Dr. Mendoza developed a test to measure boredom tolerance, right? He administered it to a group of 20,000 adults between the ages of 25 and 35. The possible scores were 0, 1, 2, 3, 4, 5, 6, with 6 indicating the highest tolerance for boredom. The test results for this group are shown in the table, right? So I'm going to show you all the table. If a subject is chosen at random from this group, the probability that he or she will have a score of 3 is 6,000 out of 20,000, right? Or 0.3, right? So in a similar way, we can use the relative frequencies to compute the probabilities of other test scores. So here we go.
Can we do this on the calculator?
And all they.
Kind of, right? So in this first table, right, we have the boredom tolerance test scores for the 20,000 people. This is the number of people that scored 0, 1, etc. Right? Now, say that we were asked the question, what is the probability of a score of 3? Right? So the question is, what's the probability of 3?
Yeah.
Now you already know what it is, right? It's the 6,000, because that's how many scored a 3, right? Over the total of everything,
Right.
which is a 20,000, right? But when you do the math on that in the calculator, this becomes what? 0.3.
But you're dividing this?
right? Yeah, when you divide it, right?
So you
Yeah,
gotta divide, 26,000 by 20,000?
yeah,
Okay.
yeah, right? So, needless to say, we know how to do that part, right? But what I want to get to is what this table is giving me, 6.2, right? We still have our scores 0, 1, 2, 3, etc., right? Exactly. Right? So this is what's called a probability distribution, right? Yeah. Just to divide each one out
By the 0.3.
by the 20,000. So for example, 1,400,
Divided by 40,000.
right, by 20,000. That's the 0.7, right? Etc. Yeah.
Okay.
So this is how you do a distribution, right? If you add
Everything?
everything together, you should get 1, right? That's
When you
it.
get 1, you know
And
Mhm.
where's the trick question? I'm waiting for it.
So the question I might ask you is like, yo, what's the probability of 5? And then you just gonna tell me like, oh, that's 0.08.
Cause it's already there.
That's
'Cause
it.
we already did,
We just have to
Yeah.
basically do for the equation of the probability.
Right.
divided by the two.
So we
Yeah.
don't write the way you're writing it, but we just divide it in our calculator.
No, you do.
But we get the.
Yeah. Yeah. So what's gonna happen is I'm gonna give you a table like this,
Okay.
right? And I'm just gonna ask you questions off of it.
Wait, but are you gonna give
Sure.
us both tables or just one?
Just one. I'm not gonna give you this table. You don't need that table. Yeah.
Forward question.
Yeah.
For example, you do a question.
Yeah.
It's just we would go through.
Well, let me-
The question-
Let me see who's paying attention. What's the probability of 4 or 5?
22.08.
What does or mean?
So I doesn't.
Okay, so do it. There's a probability of 4 plus the probability of 5, right?
Yeah.
Which is what? No. Look here.
0.08. My bad. 0.08, that's what you're looking for?
0.22 plus what?
So it'll be 0.3.
Yeah, 0.3.
Exactly. That's it. I got you.
That's how you're gonna act it, right? Like that.
So.
Exactly. Right.
Which means multiply.
And when you forget on the test, what you gonna do?
Look at your formula sheet.
Look
Good.
at Will.
All right.
Why?
We can't, because we can't work together on the final. That's why.
Thing. I remember this. It's kind of like the square root thing,
Yeah.
the table that we did.
So after the second test, do
Mm-hmm.
we work on the final after that?
Nah, we got test 3.
Test three?
Mm-hmm.
What?
And so
Mm-hmm.
Professor, it says 3, what are you talking
how
about?
many tests?
I'm trying to do 4.
You try.
Yeah. Test 4 is the fun one.
Can you get the extra credit you stop or you?
Mm-mm. But you don't need extra credit. You good. Yeah.
Professor, if the final doesn't have anything that you taught us on it.
It has everything.
Be it neither here nor there.
So
Find out the fee.
I'm sorry.
So
Say it again. Oh, you trying to copy it? I got you. Got you. Wait, hold on. What happened? With the equation? Which one? Oh, this stuff? I got you. Go ahead. Go ahead. Yeah. Mhm. I got more coming.
I don't got that formula.
You don't?
I got the album.
I got you. They have tons of those joints. Yeah.
Is
Yeah.
it?
Yeah, that's it.
Oh,
Excuse me.
But they bless you.
I mean, to be honest with you, I stole those from the tutor lab games to y'all. Formula sheet.
We like that, do them all on the floor, make it more bigger than this.
Yeah.
Them orange, it's like 9 pages.
I think that the orange paper is thicker. You know, yeah.
I put it right there.
Back in the day, we used to have them in multicolor. You want pink, you want white, whatever. Yeah. No, it's the same thing. So just to show you guys, right? This probability distribution that we have here, you can actually graph it on a histogram. Remember we spoke about histograms before, right? Where your x's right here, right? Those would be the scores, 0, 1, 2, 3, 4, 5, 6. And then the height of the bars would be your probability, right? So for 0, the probability was less than 0.1, but etc., right? Go ahead. Yeah.
We try to write this in a.
Graph
it. Graph this, why not? This is the easiest thing.
What you mean? That joint is hard.
That is
That joint is hard. Y'all actually like the histograms? Oh, I hated the histograms, but okay. I mean, but don't get me wrong though, this next test got graphs on it though.
Oh, like the slopes and stuff.
Yeah. But it's not gonna be crazy hard though.
Graph the solution of y equals minus x plus 3. You gonna give us something like that?
Something like that. I'm gonna give you a line and then you just graph it. That's it.
Okay.
All right. So these probability assignments make up the probability distribution. Notice that the scores are mutually exclusive. No one subject has 2 scores, right? So you can't have a 3 and an 8 at the same time, for example, right? The sum of the probabilities all add up to 1. The graph of this distribution is simply a relative frequency histogram, right? In which the height of the bars over the scores represent the probability of that score. Since each bar is 1 unit wide, the area of the bar over a score equals the height and thus represents the probability of that score. Since the sum of the probabilities is 1, the area under the graph is also 1, right? The top-notch clothing company needs to hire someone with a score on the boredom tolerance test of 5 or 6 to operate their fabric press machine. Since the scores 5 and 6 are mutually exclusive, the probability that someone in the group who took the boredom test made either a 5 or 6 is the sum of 5 and 6, right? So the probability of 5 or 6 is equal to the probability of 5 plus the probability of 6, which is just what? 0.08 plus 0.02, which is just 0.1. That's it. Oh, this part.
I mean, yeah.
It's right here. And so this is 5, and this is 6. Also.
Well, if you didn't have the graph, you would take the numbers on the graph, but you would on the equation.
Right. But for this particular question, I'm always going to give you that second graph, not the first one. Yeah.
But you see what he said?
Yeah.
Are you gonna do something like that and we're gonna have to compute it and make our second graph? Cause that's easy, we can do that.
But if you ask ChatGPT, they probably gonna make you do that.
I'd like to.
Like for some reason, ChatGPT just makes things so much harder. I don't know. Mhm.
I feel like it doesn't.
Because when I ask it to make up questions for me, sometimes the questions be like
They're wrong.
crazy hard. You know, they're wrong. That could happen.
Like break it down for you.
No, same thing.
After the answer, I need to.
And then sometimes they are. And then I do text where. How they break it down.
So notice that to find the probability of 5 or 6, we could have simply added the areas of the bars over the 5 and over the 6. 1 out of 10 of the group who took the boredom tolerance test would qualify for the position at top-notch clothing. So a probability distribution can be thought of as a relative frequency distribution based on a very large N sample, right? As such, it has a mean and standard deviation. If we are referring to the probability distribution of a population, then we use the Greek letter mu for the mean and sigma for the standard deviation. When we see the Greek letters used, we know the information given is from the entire population rather than just a sample. If we have a sample probability distribution, we use X bar and S respectively for the mean and the standard deviation. All right. Long story short, if you see Greek letters, right, that's population parameters. If you see English letters, that's a sample statistic.
What?
That's it. Right? Greek population, English statistic.
English like a sample.
Say it again.
Sample population.
Mm-hmm.
What was the other one? English is what?
English is sample and Greek is population.
How do I know, if it's Greek, is it gonna just be in a different language or is it gonna say?
The letter is different.
I don't look like that.
It's gonna look weird.
So like when you guys finish with this class and you guys get offered the opportunity to join Phi Theta Kappa, that's where you can use all this Greek stuff.
Oh,
All right, no problem.
can anyone see it? Send it.
Nope. I could start one though. Yeah. You got it? All right. This one? Yeah.
That's helpful. Greek letter, English letter, because this one, you can use it.
It is. Yeah.
That's fine, but you gotta compare that to the movie. If this is.
Yeah. The work to get them is the same. It's just the name is different, you know? All right, so let's look at these formula. And by the way, these are all on your formula sheet, right? So the mean and standard deviation of a discrete population probability distribution are found by using these formulas right here. So your mean mu is equal to the sum of x times p of x, right? This is called your expected value of x, right? The standard deviation sigma is equal to the square root of the sum of x minus mu squared times p of x, where sigma is called the standard deviation of x, where x is the value of a random variable. P of x is the probability of that variable, and the sum, sigma, is taken for all the values of the random variable. Note that the mean mu is the population mean, and sigma is the underlying population standard deviation because the sum, sigma, is taken over all the values of a random variable, i.e. the entire sample space. All right? Go ahead. Sorry. Go ahead. And by the way, this is all on the formula sheet. This is chapter 6. This is the last couple of questions on the next test. But you don't need to. You got your formula sheet.
Oh, no.
Yeah. Just use the formula sheet and use your calculator. You'll be good. You can borrow it from the library if you want.
We needed the calculator, but I also need the formula sheet, cause with the calculator, I wouldn't know what to plug in. You know, with the formula sheet, it gives me like a pathway of what to do, you know, cause I be getting.
I feel like that with previous work, not
Gotcha.
formulas. Formulas and me do not stick. I don't know how to grasp where to plug it in. I just memorize, that's how I.
I got you.
Yeah, like standard deviation.
I don't want you to memorize it because
Yeah.
you have the formula.
Yeah. The standard deviation.
Yeah, remember, a nurse practitioner.
Oh, slow down.
Everybody here getting a doctorate, so that's why. Of course, of course, of course. If I'm in the hospital and they mistreat me and I say like I want to speak to your manager, I'm expecting y'all to come down and be like, "Are you okay? I got you." Like I will fire this girl. What's she doing to you? All right, so.
For nursing director.
Yes.
I'm done.
All right. The mean of a probability distribution is often called the expected value of the distribution. This terminology reflects the idea that the mean represents a central point or cluster point for the entire distribution. Of course, the mean or expected value is an average value, and as such, it need not be a point of a sample space. The standard deviation is often represented as a measure of risk. A larger standard deviation implies a greater likelihood that the random variable x is different from the expected value mu. All right. That's something that you guys could use in real life, right?
What?
If the standard deviation is really large, that means that whatever you're about to do is really, really risky. You know? But should I give this patient the medication? Should I not? What's the standard deviation? 95? Nah, 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 nah. Chill, 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 chill,
Okay.
chill. Huh?
Or 95.
I'm just making it up. Yeah. But good question though, right? What's the units on that? That's true.
Right,
Yeah.
like
You know how to take
like
vitals?
the mean, you're gonna do mean, like the average of patients, so they're gonna ask,
Mhm.
I have like 3 patients,
Yeah.
beats per minute for 60 seconds, and then I, do the mean, whatever,
Hmm.
and that's my average.
True. True, true, true. All right, let's talk about an example real quick. Still copying?
Some
Yeah.
nurses have calculators,
Huh?
I've seen them. Some nurses
I mean, they
have
got,
little calculators,
don't they got a whole computer that be on wheels?
annoying, they.
I mean,
They
but
do
the
it on paper.
computer could do everything. So, all right, let's look at this expected value standard deviation. So, are we influenced? That's an example. Are we influenced to buy a product by an ad we saw on TV, right? National Informational Marketing Association determined the number of times buyers of a product had watched a TV infomercial before purchasing a product. The results are shown, right? So on the first row, we have the number of times buyers saw an infomercial, right? 1, 2, 3, 4, or 5, right? And then it says this category 5 or more, but will be treated as 5 in the sample, right? Now, the second row, this is the percentage of buyers. So these people saw the commercial, they bought it, right? This is the likelihood that they would buy whatever after seeing the commercial, right? Okay. We can treat the information shown as an estimate of the probability distribution because the events are mutually exclusive and the sum of the percentages, so when you add up all these percentages, is equal to 100%. This is to compute the mean and the standard deviation of this distribution. All right. Not too bad, right? So look, just keep it simple. What's my x's here?
You're what?
My x's. It's just the number of times the buyer saw, right? Yeah, so this is 1, 2, 3, 4, and 5. All right. And then the percentage of buyers, right? This is my P of X. Literally just copy it. 27%, 31%, 18%, 9%, 15%. Now to find the mean, right? Remember the mean is what? Mu is equal to the sum of x times p of x, right? So I need another column, right? Called x times p of x. Literally just multiply these two together. 1 times 27%, that's 0.27. 2 times 31%, that's 0.62. You get the idea, right? What's 3 times 18%? What is it? In your calculator, that would be 0.18 times 3. Okay, 0.54. And what is 4 times 9%? What is that? Okay, so 0.36. And then 5 times 15%? 0.03 for 5 times 0.09 times 4.
0.36.
0.36, right?
The X.
And what about 5 times 0.15? What's that?
0.75.
It is?
You said 0.015, right? Or
0.15 times 5.
0.7.
Okay. That doesn't seem right though. It could be though. Yeah. Yeah. The first two columns are multiplying together. And then I get the third column. Yeah. Yeah. So like this one is like 1 times 27%.
Yeah.
And then this one is like 2 times 31%, etc. All right. All right. Anyway, I want my mean, right? And I'm telling you, my mean is just the sum of x times p of x, which is what? You just add up all these numbers and that's it. Right? So that's 0.27 plus 0.62 plus 0.54, etc., etc. So what's the answer? Tell me. Okay. And that's it. Questions on this? Say it again.
Graph that X times
Uh-huh.
based on we had to add the times 2 times.
Yeah. That's all you're adding is these numbers here.
This is called the what? The standard deviation.
This is the mean, right?
So why
Yeah.
can't you? Why?
Mhm. Yeah.
Mm-hmm.
And then after that now, we can do the standard deviation. Standard deviation is a little bit more complicated. I'm gonna erase this. Yeah, and then that's it. But a standard deviation, we need a little bit more. So the first thing is we're gonna need a column that is x minus mu squared times p of x. Just plug it in, right? What's my x here? 1 minus my mean. What's my mean? 2.54 squared times my p of x, which is what? 0.27. And then what do I get?
And I can't do that.
Yeah.
Well, I could, hold on, I'm thinking on.
And then just do the next one.
I have this calculator, I just have to times 2, right? For the square root, for the
Um,
action.
no square root, just square it. Turn it sideways. Yeah. Yeah. 31%. Yeah. But you guys get the idea with this, right? So
The first one,
when you add all of this stuff up together, right? This would be the sum of x minus mu squared times p of x. When you add all of that up together, you're getting the variance, right? So this is your variance. Well, actually, wait, right?
they're back. Once you get the, everybody go to the first, for the next.
For the fourth column, yeah. Now, the standard deviation, which is what they asked you for, is always what? The square root of the variance, right?
Is that the variance is always gonna be 0?
Well, no, the variance for this is the sum of whatever this last column is, you know?
Oh, I see,
Yeah.
everything.
Right. And that's it. Questions on this? I could finish this, but that's gonna take time. I know we only got like a minute left. Yeah, yeah, yeah. This is not bad, right? This is pretty much your whole homework. Mhm. Yeah, yeah. See you.
Back to the 16.
You can do it yourself. You can do it online. Whatever.
Like, I'm not even, I'm personally not sure about, maybe that another test coming. I might.
It just takes 2 seconds.
I don't know. So, like, I'm really aggravated.
Wait, can I copy you?
What's just morning, I had to do, what's the third one called? Variance.
Variance.
Good night.
Good night. See you. Remember, we have time for the test. The test is not till like next week, end of next week. Yeah.
Go down.
We got mad time. Like 2 questions on it. Think so?
That's a lot. Yeah, not sticking right away.
When you do the homework, it'll stick. I promise.
We do the homework.
Yeah. But this homework is new though.
Repetitive,
I got you.
like worksheets, I don't know, worksheet maybe. I like worksheet, yeah.
You can turn your homework into a worksheet. You know that?
I didn't know that.
Yeah, there's a button that you click. Let me see. Go ahead. What you call it? Do the test corrections and then complete all the homework. Okay. Yeah. Are you too, man? I'll see you.
420.
So for the standard deviation, which wherever the variance, the
Um,
total of everything goes back
yes, yeah.
times what? Or not?
No times. Just added all the numbers and that's it.
And then you square with the answer and that's your answer?
Yes.
Bye, baby.
Bye. I see you. Bye.
Okay.
But I want to answer your question real quick.
The one that I got wrong with that.
it's a plus. I'm going towards the one I'll still just stop and so much attention.
That's fine.
Right, so it's the end, right? So right, we do these first.
Perfect.
These first, so like we times it by itself and then.
Well, subtract it first, then square it, then times it by that.
Oh, we subtracted. Okay,
Yeah.
that's what the negative is.
Yeah.
Subtract it first. Once we get the answer, we times it by itself.
Right.
And then,
And then multiply times the 0 point whatever.
okay.
And then that's going to be the first one. Then you do for the second one, the third one, all of that. And then when you get all of them, you add up all these numbers, and then that's going to give you your variance.
Okay, so the variance. Okay. Yeah, like, so we add them all together then?
Yeah. At the end, when you get all the numbers. So Natalie, let me show you. So
Wait, let me get the median.
but look, real quick, look. So this is web work, right? Let's say that I open up a homework, right? Like let's do, I don't know, 5.2, for example, right? So I have it opened here. Right here where it says download as a PDF, you click that, and then you can actually make it into a PDF and print it, and then you can, act like a worksheet with it. And then
Same problems?
same problems. And then when you get the answers, just go here and then click it and just write the answers and then click submit to see if they're right.
Do you
That's
think we can? Cause I don't know, I just think it's a lot to grasp in such little time. Even though we can go over the homework and we do go over it at home,
Yeah,
it's just not, I don't know. I just feel like I'm not understanding.
I promise you, you're good.
I don't feel.
You're not gonna fail.
I feel like it's not, I don't know, I just feel like there's another